So these are the Padlet questions that people asked this week, and I wanted to take a minute and just kind of go over the answers. I'll try to keep this short, but the first checkpoint problem in the book, where you're given that tan of x is equal to 1/3, there's a second piece of information that's given to you that's really important, and that's that cosine of x is less than 0. So I posted this response, and we're going to use both pieces of information to help us to figure out what's going on. If we know that tan of x is positive, right, it's equal to 1/3, and cosine of x is negative, then we know that we're sitting in quadrant 3. From there, there's a lot of different ways that you could process this problem, but in my opinion, the easiest way, use the reciprocal identity to find that cotangent of x is equal to 3. And then you can use one of the alternate forms of the Pythagorean identity to either find secant or to find cosecant if you were to use the cotangent function. I apologize for the sloppiness of the math here, but in essence, using the Pythagorean identity gives you that secant of x is either equal to positive or negative square root of 10 over 3. And then from there, we're going to use the fact that we're sitting in quadrant 3 to determine that secant is negative in the third quadrant. So we can find the value of secant to be negative square root of 3, which means through the reciprocal identity that cosine is equal to negative 3 over the square root of 10. And then we can use the Pythagorean identity again with cosine to find sine, and then the reciprocal identity to find cosecant. So hopefully that makes sense. If it doesn't, let me know. When I first read this question of the decimal point and converting it to a fraction, I thought, oh, well, how do we convert from one to the other? To convert a decimal to a fraction, you just read the decimal in terms of the fraction, but for trig, that actually becomes very difficult because most of the decimals that we're dealing with are irrational, non-terminating, non-repeating decimals. And so the terrible answer is that you kind of figure it out through practice. I'm old enough to where calculators didn't give you irrational answers. Now there are calculators that would tell you square root of 2 over 2, and then you can convert that to a decimal. Through practice, you start to learn that when you see 0.7071, that is the square root of 2 over 2. I believe the square root of 3 over 2 is 0.8661. So it's really through practice more than anything else. But I did make a statement down here that is one reason why it's important to have a sense of those special triangles or the unit circle and what those values are. The explanation of what cosine x less than 0 means. In general, we're using that piece of information to determine which quadrant things are in. So if you're a unit circle person, the cosine being less than 0 means that the x coordinate is negative, which happens in quadrant 2 and quadrant 3. If you're, like we talked about in class the other day, and all students take calculus, where the letter tells you which function is positive or negative, the S in quadrant 2 is for sine, and the T in quadrant 3 is for tangent. So in those two quadrants, the cosine function is negative. And as we said for this first one, knowing that cosine is negative means that we get some information that we really need. I apologize now. This is the worst answer I've ever given. How do you know when to stop simplifying? You kind of just know because you can't do anything more. It's an awful answer, but when you first started in algebra, the question was, when do I stop combining like terms? And over time, you started to realize that, when you don't have any more like terms, you stop combining. In trigonometry, the goal is to get things down to a single function. And usually we want to have it written in terms of sine, cosine, or tangent, or an expression that cannot be simplified further. And through trial and error, you kind of get a sense as to when you're done. And then anything else you do is actually going to complicate the expression more than anything else. this last question, does 1 plus cosine of x equal sine of x? No, it doesn't. And I'm not sure exactly where the 1 plus cosine x equals sine of x came from, like whether you were taking the square root of the Pythagorean identity. That was my first thought, but the math doesn't really work out. In general, proving things are not true in math just means coming up with one counterexample, and proving things are true means you got to prove that they're always true. So I took the one counterexample opportunity. If x was 0, whether it's 0 degrees or 0 radian, cosine of x is equal to 1, right? That's the x coordinate on the unit circle, and sine of x is equal to 0, which in this relationship would give us 2 equals 0, which is not a true statement. So that is definitely not a true thing. In general, any angle that had a positive cosine, we would end up with an impossible situation because the sine of x can never be greater than 1, what it's equal to. And so 1 plus any positive number is going to be bigger than 1, and then we have an impossibility. So I'll try to do this every week where I'll just kind of answer your questions. I'll post the answers as well. That way you can read them or kind of listen to the explanation. And we'll use these questions to help guide the conversation when we meet in class.